Antiderivatives involving logarithmic functions. Antiderivatives follow directly from knowing derivatives. All right, now let's back up a little bit. We know our power rule, and we know that the power rule only holds for exponents that are not equal to -1. Any exponent except for -1, you can use the power rule. So what do you do if your exponent is -1? We now know the answer to that question. The antiderivative is the same as the antiderivative of 1 over x, and the antiderivative of 1 over x is log of the absolute value of x. We're going to do a bunch of examples where we have to do a u substitution. So let's get started. This one, we want to do a substitution with u equaling 4x minus 3. If we do that substitution, then du equals 4 dx, and dx equals a fourth of du. Do your substitution, and then find the antiderivative using our new log rule. Then substitute back. Let's do another example. This is another example where having u equal to the denominator will work. So let's have u equal to x squared plus 9. And in that case, du equals 2x dx. Now, this works only because there's an x in my numerator. If there wasn't that x in the numerator, I wouldn't be able to use this substitution. So x times dx, solving for that, and I get a half of a du. Next, let's work on the bounds. If x equals 0, what is u? Well, if x equals 0, u would have to equal 9. And if x equals 4, u would have to equal 25. We're now ready to do our substitution. When you do your substitution, changing from x to u, then when you're all done, everything should be in terms of u, including the bounds. Let's find the antiderivative. After finding the antiderivative, you evaluate. And we have 1/2 log 25 minus 1/2 log 9. Then I use my difference rule. Notice that 25 over 9 equals 5 over 3 quantity squared. Bring the 2 out and I get log 5/3. Here's another problem where choosing the denominator to be u works very nicely. Have u equal to sine x. Then du equals cosine x dx. And this turns out to be a pretty straightforward problem. Find the antiderivative and substitute back. Now, this is pretty interesting because what we just discovered is that the antiderivative of cotangent is equal to the log of the absolute value of sine x. So we now know, we've known the antiderivative of sine, cosine, and tangent. Now we also know the antiderivative of cotangent. And here's the antiderivative of secant and cosecant. We'll talk more about this subject in the next part. So take care and have a great day.